We're going to look at section 6.1 about graphing systems of equations right now. When we solve by graphing, which is this first section, we are looking for graphing two lines, sort of like in this way, and finding the place where they meet. That intersection point, that is the answer. An x and a y value that designate that point. So the job to do is to graph these two equations. That means you need to use your graphing skills, and the two main ways to graph are either by using an xy table of values or by changing it to slope-intercept form. So I'm going to do both of these as an example of doing them. This one, I am going to do an xy table. This one I'm going to change into slope-intercept form. I'll do that first because that's an easier way, in my opinion, to do this. Negative y equals negative 2x plus 4. Remember when you do this kind of thing that you take the x term and you put it right after the equal sign. And if there's a negative with a y or any variable, you keep it with it until you change it or get rid of it by dividing by a negative 1. And then I divide that into both of the terms on the other side. Let's increase this size. That gives me y equals 2x minus 4. I'm going to graph that one first. Let's go over to negative 4, and I'm going to go up 2 over 1, because this gives me a slope of 2 over 1. Up 2 and over 1, and up 2 and over 1, and up 2 over 1. I can treat that as negative 2 over negative 1, because that's also mathematically the same as that, and that helps me to go down 2 and over 1 the other way, and it makes for a better a better and easier to draw line. So let's use a straight edge to draw that line. So one of the points on this line is going to be the correct answer. When we graph the other one and intersect that line, we will get that correct answer. So let's put 0 in. I'm going to put 0 in here. And I'm going to put in a couple of other numbers, such as, I guess I could just use negative 1 or negative 2 or positive 2. I'm going to put 3 numbers. Negative 2, 0, and positive 2. You could do 1, 2, and 3. You could do 0, 7, and 20. You can do 5,008,300, whatever. You should keep two x values that are on here, and usually around 0, the ones around that are the easiest ones to work with. So if I put a 0 in for the x, cover it up because it's now times 0, divide by 3, that means y is equal to 4. If I put a positive 2 in here, that's the number 4, and if I subtract 4 on both sides, I get 8. So then I divide it, 8 over 3. Now for graphing purposes, that doesn't help as much as perhaps 2 and 2/3 might help. 2.67 could help too, but 2 2/3 will be a little easier to estimate where it's at on here. And then if I put negative 2 in here, 2 times negative 2 is negative 4. And if I add 4 to both sides, I get 16. 3 goes into 16. That's going to be 16 over 3, which is also equal to 5 1/3. So now I will graph those, 0 and 4, at positive 2 and 2 2/3 is about here. Negative 2 and 5 1/3 is about here. So it looks like we can still get a line out of it. You see why it's hard to work with fractions or decimals on a graph, which is why I do not really prefer this method very much. Sometimes you can get numbers that do not have fractions or decimals, but doing it with the slope and intercept, to me, is a good deal easier than this method. It is entirely your choice which method you wish to do, though, as long as you can get the correct line drawn in the right place. And in this particular case, now that we've graphed that one, we have a point here where they both meet. And that point is at 1, 2, 3 for the x and 2 for the y. So we've identified that x is equal to 3 and that y is equal to 2. If you put that as your answer, it's wrong. You will get a point off on the test for that. Because this is a point on a graph, and you have to show it therefore as an actual point in parentheses as a coordinate point. So the correct answer is -3 and 2. That's the way I want to see that. Okay, now let's do this next one. In this case, I'll do the same thing where I'll do one of them by changing it to slope-intercept form and one of them by doing an XY table. Okay. So I'm going to do this one by changing it. I'm going to add 3x to both sides, so I'm going to get y equals -3x minus 2. And I'll graph that one. I go down to where -2 is, and I have a slope of -3 and 1, -3 and another 1. I can make that 3 over a -1, so I can go the other way, but it's still the same line. 3 and -1. It just allows me to go to the other part of the graph and give me more dots to draw a good line with. Oh, remember also that you must always put arrows on lines, and the line needs to go all the way through the graph. If you were to do a smaller one, like I'll do incorrectly on the next one, and you'll see, oh, that one's not supposed to be that way. So this one I'll do an XY table. I'll put 0 in the middle. If x is 0, here I get 2y equals 10 and divide by 2, and that gives me a 5. So let's do -1 and 1 this time. If I put -1 in here, that makes -6. Oh, I'll do it this way. That's -6 plus 2y is equal to 10 because of -1 times 6. And then I'll add 6 to both sides. So I get 2y is equal to 16. When I divide by 2, I'm going to get an 8 here. And if I put 1 in there, I get 6 plus 2y is equal to 10. Subtract 6 and I get 2y is equal to 4. So when I divide by 2, I get 2. So that means at 0, I'm at 3, 4, 5. At 1, I'm at 2. At -1, I'm at 8. So if I do the line like this, well, I just lost a point on the test because the line is supposed to go all the way to the end of the graph. That would be better. And now I see two parallel lines. Parallel lines. And what that means is that they never intersect. They never touch anywhere. If I were to change this into slope-intercept form, I would see that it would have a slope of -3. And when both lines have the same slope, and they don't meet at the same place for the y-intercept, that means that they're parallel. They're not the same line, but they're parallel to each other, so they never intersect. You are not going to find a point like this one where they meet. But that's not what you say. The answer that you give is to say, essentially, it's not possible to have an answer here, or to have a solution. So the phrase to use is no solution. And I want to see that one. Although there's other ways to do it, I just don't want to deal with all the various possibilities. Just say no solution. And get used to that because you're going to have quite a few other types of problems where that's true in the future. Okay, now let's look at two other graphing ones. Okay, so for this one, x minus 4y equals 20 and 5x plus 5 equals 5. And I'm going to change that one to 8x minus 4y equals 20. And this one, I'm going to do an xy table for. And if I do an xy table here for this one, okay, I could do that, but you know what? That would be so much easier if I just do it. Well, I guess I'll do it anyway. If I put 0 in for the x, I'm going to get, divide by 5, I'm going to get a 1. Now, if I put 2, well, I guess I'm going to go my 2 and my -2 again. If I put 2 in here, I'm going to get a 10. And then I'm going to get, subtract it, I'm going to have 5y equals 5 take away 10, or negative 5, which means it'll be a negative 1 here. If I put negative 2 in here, I'll have negative 10, and I add it, I'm going to get 15. I'm going to have 5y equals 15, I'll get a 3. 0 and 1, 2 and negative 1, negative 2 and 3, let's get that line drawn. And now the other one, I'm going to change this to subtract 8x. Negative 4y equals negative 8x plus 20. Divide by negative 4. Y is equal to 2x minus 5. Okay, so I'm going to come down here to 5, negative 5. 1, 2, 3, 4, 5. Up by 2 and over 1, up by 2 and over 1. Oop, I see where they meet now. Let's draw the line through it. And it looks like this place is 2 and negative 1. So 2 and negative 1 would be the answer for this one. Put a box around it. And now here for this one. This is already in slope-intercept form. So let's go to the y-intercept and then a slope of 2 over 1 numerous times, or negative 2 and negative 1 for the slope. And I will draw this line. And then here, well, I have a number of ways to do it, but to me it's still easier to put it in slope-intercept form. Y is equal to 2x minus, minus here, minus and minus makes plus. Oh, that's interesting. This is the same as that one. So if I graph it right on top. It means every point for this equation is the same as every point for that equation. And that means there's an infinite number of points on this line which satisfy both of these. And the phrase for that is infinitely many solutions. So sometimes you have no solution, such as a parallel line, and sometimes you have any possible x and y value will be a solution if it's true for one line and it's true for the other. So you'd say infinitely many solutions for that one.